Hey everyone, and welcome back to The Explainer. I am super excited you're here today because honestly, we're tackling one of the most critical transitions in your entire data science journey. We're talking about moving from those safe, clean, perfectly organized Jupyter notebooks into the wild, totally unpredictable world of industry-level production systems. Look, over my 10+ years as a senior machine learning engineer, I've seen exactly what separates a junior data scientist from a true senior engineer. And today, I'm going to mentor you through that exact shift. We are diving deep into MLOps basics and how to actually manage machine learning models in a real production environment. So picture this. You trained a gorgeous model. You deployed it, it was absolutely perfect. But then, after 3 months out in the real world, the accuracy suddenly just plummets. So who's responsible? Is it the data engineers, the software team? The hard truth is, in production ML, your responsibility doesn't just magically end when you hit export. There is this massive gap between the clean data sets you get in a classroom and the messy, constantly shifting reality of live user data. And if you aren't prepared for that reality, your models are absolutely going to fail. Okay, let's lay out our roadmap for today. We'll start with the reality of production, then map out the real-world ML lifecycle. After that, we'll talk about why just saving your model isn't enough, build a hands-on churn pipeline together, discuss monitoring after deployment, and finally, wrap up with how to build a serious MLOps career. All right, part 1, the reality of production. This is all about understanding where machine learning meets DevOps. I like to think of the traditional data science workflow, gathering data, tuning hyperparameters, training the model, as creating a brand new car. It's engineering, it's design, it's building something incredible from scratch. But here's the thing, a car doesn't just run perfectly forever on its own, right? The production workflow, which is what we call MLOps, is everything that comes after it rolls off the lot. It's maintaining the car, it's checking the engine performance, changing the oil, and updating parts as they inevitably wear out. Companies desperately need MLOps because a machine learning model is a living system. If it isn't actively maintained, it degrades. Fast. Let's move to part 2, the real-world ML lifecycle, or as I like to call it, the continuous pipeline. In a real company, your data and your model go on a highly structured journey. It kicks off with data collection, moves right into data validation to catch any garbage inputs early, and then flows into feature engineering. From there, we hit model training and testing, and then deployment. But notice something absolutely crucial here. It doesn't stop at deployment. Deployment immediately feeds into monitoring, which then triggers retraining when the performance inevitably dips. It's not a straight line. It's a continuous automated loop. Take it from a guy who has spent a decade in the trenches. If you build this loop right, the system literally heals itself. If you don't, well, get ready for your pager to go off at 2 a.m. because your model just silently crashed in production. Which brings us to part 3, beyond saving the model. We need to talk about the versioning problem. So, one of the biggest traps I see junior devs fall into is the old way. They think a model is totally finished once they export a file, just saving that trusty model.pkl right to their hard drive. But in production, that is a total nightmare. Think about it. If something breaks, how on earth do you know what data that specific model was trained on? The MLOps way means you are rigorously tracking the specific model version, the exact dataset version, the exact parameters, and the performance metrics at that exact moment in time. You must be able to recreate your results on demand, no exceptions. To pull that off, we rely on a very specific stack of industry-standard tools. Now, you're probably already familiar with Git for tracking your code, but we also bring in tools like MLflow, which is honestly fantastic for tracking all those hyperparameter experiments and metrics. And then there's DVC, or Data Version Control. It acts exactly like Git, but it's built to handle massive multi-gigabyte datasets without crashing your machine. All right, part 4, let's get our hands dirty with a hands-on churn pipeline and actually talk through some production code line by line. Imagine we're building a customer churn prediction model for a business. We aren't just hacking this together in a messy notebook cell. We're writing a clean, professional Python script. We used pandas to set up our data loading pipeline, pulling in the absolute latest customer usage behavior. Then we initialize our core model training logic, say an XGBoost classifier. The key here is that the code is clean, it's modular, and it's fully prepped for automation. Now, here's where the magic happens. Instead of just dumping a pickle file into a folder, we wrap our training loop inside an MLflow block. We are programmatically telling our script to actively log our accuracy, our loss metrics, and every single hyperparameter directly to a centralized server. Because we do this, Anyone on the engineering team can just pull up a dashboard and see exactly how this specific run performed and exactly what parameters made it happen. And because we use that robust versioning, we can easily write a simple script to seamlessly load a previous model. This is your ultimate safety net. If our newly deployed churn model starts hallucinating or if its accuracy just totally tanks, our system can instantly query MLflow, grab the last known stable version, and restore production in a matter of seconds. Honestly, having this kind of failsafe is the true hallmark of a mature MLOps system. Moving right along to part 5, monitoring after deployment, or as I call it, watching for drift. Like we talked about, deployment is just the starting line. Once your model is out in the wild, it is under constant attack from invisible enemies. We obviously have to monitor for an overall accuracy drop, but we also have to watch like a hawk for data drift. That's when the real-world data starts fundamentally shifting away from the data you actually trained on. We're looking for sudden prediction changes, where maybe the model starts skewing heavily toward one specific output. And we watch for feature changes, where maybe an upstream database accidentally altered how a specific variable is calculated and fed to our model. Let's put this into perspective with some real-world examples across different industries. Take a bank fraud model. Drift there often looks like a sudden change in predictions. Scammers are smart. They constantly invent new tactics. So if your model suddenly stops flagging transactions that it used to catch effortlessly, the real-world behavior has drifted. In a recommendation system, like for an e-commerce site, you might see feature changes. Maybe users are clicking differently because the website completely redesigned its layout. And for the churn prediction pipeline we just talked about, drift usually reveals itself as a slow, agonizing drop in accuracy over several months, simply because customer preferences naturally evolve over time. Finally, let's hit part 6. Building an MLOps career and what the industry actually demands from you. I want you to really internalize this statement. Senior data scientists don't only build models, they build systems that survive in production. If you take away anything today, let it be this massive mindset shift. Hiring managers at top tech companies are not looking for someone who can just tweak hyperparameters in an isolated, perfect environment. They want engineers who can build resilient, self-healing systems that actually survive contact with the real world. So, how do you become that highly sought-after engineer? Here is your ultimate skill roadmap. Yes, obviously you need Python and deep machine learning knowledge, but you also absolutely must master APIs to serve your models. You need to learn Docker so you can containerize your applications and make them run consistently anywhere. You have to understand cloud infrastructure, whether that's AWS, GCP, or Azure. And of course, you need the MLOps principles we unpacked today: versioning, monitoring, and continuous retraining. We have covered a massive amount of ground in this explainer, from the harsh reality of maintaining live systems to the exact code needed for versioning and tackling those invisible enemies like data drift. You now have the MLOps mindset. But remember, your journey into production ML is literally just beginning. Building systems that survive requires continuous, relentless learning. So I'm going to leave you with this question. What piece of the production pipeline are you going to master next? Are you going to dive headfirst into Docker? Or maybe master MLflow? The choice is entirely yours. Keep learning, keep building those resilient systems, and I will see you in the next explainer.